Greetings, students. Here we are again, thinking about logic in the midst of a global pandemic. What else do we have to do with our time? And let's think about truth tables and validity. Think again about what a valid argument is. A valid argument is an argument that's an instance of a valid argument form. An argument form is valid if and only if it's impossible to have all true premises and a false conclusion. So if the premises are true, remember that if the premises are true, it's impossible for the conclusion to be false. When we analyze an argument with a truth table, there will not be any row, or possible world if you prefer, where all the premises are true and the conclusion is false. An invalid argument, of course, simply sort of reverses that. It's an argument that is not an instance of a valid argument form. An argument form is invalid if and only if it's possible to have all true premises and a false conclusion. So if the premises are true, it is possible for the conclusion to be false. When we analyze an argument with a truth table, there will be some row or possible world where all the premises are true and the conclusion is false. So by this time, you should be familiar with the form of modus ponens that we've looked at several times now. For example, if I say, if I'm a hobbit, then I love second breakfast. I am a hobbit, therefore I love second breakfast. And we symbolize it and translate it using our dictionary. We get this form. If P, then Q, P, therefore Q. And you've learned to say or accept that since this is a valid argument form, any possible substitution instance of it is valid as well. But you don't have to take my word for it. You can prove modus ponens is valid in any other of the famous forms we've studied. As you can see here, I'm using the method I've taught you where we use the word processing program to generate a table to assign truth values. And remember why I'm putting the slashes in will become clear in a minute. Remember, first you highlight this, right? And then you go up to Insert, Table, Convert Text to Table. Where it says Other, you put in a space and hit OK, right? And now I have that. And I can go, and since I have only two variables, P and Q, that'll give me 4 lines to my truth table. So tab, 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 I have 4 lines. Go ahead and make that a little q again so it fits in our system. And I've done this so I can separate out the premises and the conclusion and not get them mixed up. So I'm just going to grayscale that and grayscale that. And now I want to number my premise. There's premise 1. There's premise 2. And I'll put my conclusion indicator there, and there's my conclusion. Now I put in my truth values. I'm going to hit caps lock. True, false, true, false, true, true, false, false. I then assign my truth values wherever they belong. So I'm doing Q right now. And then there's a Q there. And then I assign the P's. And so I want to get the truth value for premise 1. True, then true is true. True, then false is false. And that's true. And that's true. And I'm done with these truth values. And I'm done with these truth values. And I have the values under the major operator. So I indicate them. This is already done. This premise is already filled in. Just to make it look neat, I'll go ahead and put it right under the P. And this one's already done for me too. All right. Whoop. Just trying to make it look neat and pretty. There we go. And so that's the values I'm interested in there, and that's the final values there. Now what I want to see is there any line or possible world where I can have all true premises and a false conclusion? True, 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 false. And really all I have to look and see is wherever there's a false, can I have two truths? Can I have two truths there? No. How about there? Can I have a false conclusion and two true premises? No. So this proves that that's a valid argument form. Remember also, we learned not to confuse these two forms, modus ponens and the fallacy of affirming the consequent. Not to confuse P then Q, P therefore Q, and P then Q, Q therefore P. If I'm human, then I'm a mammal. I'm human, I'm a mammal is valid, but if I'm a human, then I'm a mammal, therefore I'm a human is invalid, because my cat or dog are mammals, but they're not humans, so they often think they are. But again, don't take my word for it. You can evaluate the fallacy of affirming the consequent for validity. Once again, I generated the truth table through the method we just looked at, right? And there's my premises, my two premises and my conclusion. And when I assign the truth values, I got true then true is true, true then false is false, false then true is true, false then true is true. And these are already done. Now I go looking. Wherever I have a false, can I have two? There we go. I have a case where I have all true premises and a false conclusion. So this form is invalid, since it's possible to have all true premises and a false conclusion, as seen in line 3. On the exam, if I give you an argument to evaluate and you find it, I'll say explain your results. I'll look for a sentence, something just like this one, explaining what's going on and how the truth table lets you know that the argument's invalid. And perhaps you remember modus tollens, which we've studied as well. If Lady Galadriel takes the Ring of Power, then she will become a Dark Queen. But it's not true that Lady Galadriel becomes a Dark Queen. So it's not true that Lady Galadriel takes the Ring of Power. Right? And if we symbolize that and abstract to the form, P then Q, not Q, therefore not P. And up to this point, you've had to take my word for it, that this is a valid argument form, and any possible substitution instead of it is valid as well. But don't take my word for it. Once again, we generate a truth table. We have our first premise, our second premise, and our conclusion. And if we work through doing all of those, true becomes false, false becomes true, true becomes false, false becomes true, true, false, false, true, true then true, true then false, false then true, true, and false then false is true. Let's go looking. Wherever we have a false conclusion, can we have true premises? Not there and not there. Since there's no line where we have all true premises and a false conclusion, this argument form is valid, and so is any instance of this argument form. Remember, we also learned not to confuse these two forms, modus tollens and the fallacy of denying the antecedent. We learned that P then Q, not Q, therefore not P, is not the same as P then Q, not P, therefore not Q. If I'm a human, then I'm a mammal. I'm not a mammal, I'm not a human. It's not the same as if I'm human, then I'm a mammal. I'm not a human, so I'm not a mammal. That wouldn't make any sense. So we can evaluate the fallacy of denying the antecedent for validity as well. Once again, I've generated the truth tables. Remember when you generate it using the table maker to put a space between that and that so you get two different columns, right? And we've got the true, false, true, true, and then that reverse truth values, and that reverse truth values. And we go looking. Wherever there's a false, yep, and there's a false and two true premises. So this argument form is invalid. It's possible to have all true premises and a false conclusion, as we can see here on line 3 of the truth table. Perhaps you'll remember this argument from earlier in the semester. I said it was a very famous one in the history of philosophy. Premise 1, if something is good because God commands it, then what is evil to us can be good. 2, if God commands it because it is good, then the good is greater than God. 3, either something is good because God commands it, or God commands it because it is good. Therefore, either what is evil to us can be good, or the good is greater than God. So we symbolize that with our dictionary. It becomes if B then E, if C then G, B or C, therefore E or G, which gives us a form we know as the constructive dilemma. If P then Q, if R then S, P or R, therefore Q or S. And that gives us 2 to the 4th power, or 16 possible worlds, or lines on our truth table. So, we've generated our truth table. We have 4 variables, so we have 16 lines. 2 times 2 is 4, times 2 is 8, times 2 is 16. I've generated my columns, marked off premise 1, premise 2, premise 3, and the conclusion. And now notice, I'm going to do the conclusion first. Why do the conclusion first? I'm trying to find if it's possible to have all true premises in a false conclusion. If the conclusion is true, it is obviously impossible to have all true premises in a false conclusion. So I don't have to worry about this line, this line, this line, this line, or this line, but I do have to worry about this line because it's possible to have a false conclusion with all true premises, and that's what I need to test. And similarly here, and here, and here. But those are the only places I need to worry about. So let's go to this line, and here we have true then false, which becomes false. So at this point I can just stop. Why can I stop? Again, I'm trying to see if I can have all true premises in a false conclusion. If the first premise is false, I can't have all true premises. So I can't have all true premises in a false conclusion, so I can go ahead and go to this line. Same thing happens here. True then false is false. Again, I don't have to worry about this line anymore because I can't have all true premises in a false conclusion. What about this one? False then false is true, but true then false is false. Once again, I can stop. Second premise is false. I can't have all true premises in a false conclusion. That leaves one possible chance to make this argument form invalid. False then false is true. False then false is true. But false or false is false. Once again, I can't have all true premises and a false conclusion. And I don't want to forget to mark out the values I've used so that it's clear, it's clear what I'm doing, right? And make sure you mark out the things on the exam as far as you take them so that I can see exactly what's going on and check your work. So it's probably a good idea is to go ahead and mark out those values right when you do them instead of coming back and marking them out like I'm doing now. Okay, false, then false was true, and false, then false was true, and false or false is false. So in my example, in my explanation, I would say when we analyze this argument form with a truth table, we find it's impossible to have all true premises in a false conclusion. There's no line in the truth table where we have all true premises in a false conclusion, and so this argument form must be valid. Now, it's been a long road to get to this point, but remember where it all started. We said that a proposition is the meaning of a declarative sentence. And so it's not an exclamation, command, or question. It's what the sentence asserts or claims to be the case, and so must be either true or false. It's not identical with the written or spoken sentence. As it is raining, il pleut, and es regnet all assert the same claim or have the same meaning. We then learn that an argument is a set of propositions, where one proposition, the conclusion, is deduced from at least one or more other propositions, the premises. The conclusion follows from the premises, which lead to the conclusion and support it. We then learn that logic is the study of argument. We study the methods used to deduce or produce a claim, and then determine whether or not the argument is good or not. In particular, we study the methods for evaluating whether or not the premises of an argument give support for the conclusion. We learn that arguments, or an instance of an argument form, are valid and invalid because of their logical form. Or let me just start that again. Arguments, by that I mean instances of arguments, are valid or invalid just because of their logical form. So any individual argument instance is valid if and only if its form is valid. We then learn that an argument form is said to be valid if and only if it's impossible to have all true premises and a false conclusion. A valid argument is then an argument that's an instance of a valid argument form. So if an argument is an instance of a valid argument form and it has all true premises, then it must have a true conclusion as well. Thus, the conclusion of a valid argument can only be denied if you also deny at least one of its premises. Anyone who accepts the premises as true must accept the conclusion as true as well. Also remember, the terms valid and invalid have a very specific meaning in logic and philosophy, but it's not used like this in everyday speech. In everyday speech, you might hear the contract is valid, by which we mean something like the contract is legally binding. Or you might hear somebody say, that's a valid point. And they mean by that the point is relevant or has some sort of legitimacy. But in logic, valid and invalid refer to properties of arguments as a whole and not of individual claims. In logic, there is no such thing as a valid claim or statement. That would make absolutely no sense at all. In thinking about arguments, we thought about the idea that we claim one proposition, the conclusion, to be true on the basis of other propositions known as the premises, which provide evidence for the conclusion. When we argue in this way, we seek to prove or justify the conclusion through an act of reasoning. We say that we deduce the conclusion from the premises, or that the conclusion follows from the premises. Let's try to be more precise about that now. Suppose I argued, if Ray is a Jedi, then Ray is Force sensitive, and Ray is a Jedi, therefore Ray is Force sensitive. The claim is that the conclusion follows from the premises, that it is deduced from the premises, and that the premises support the conclusion. But we could, symbolize it with our dictionary and get if J then F, J then F to abstract the form, if P then Q, P therefore Q. And you can see here that just by looking at the variables, like just by looking at modus ponens, you can see that this premise and this premise support or lead to this conclusion. The point is, the conclusion follows from the premises even when placed in the form of variables. The conclusion follows because of its form and not its specific content or meaning. Which is not to say that the truth doesn't matter. Truth still matters. The key point here is not whether or not the claims are true, but that if they are true, then the conclusion must be true. It's the hypothetical nature of the reasoning that it's important to grasp. If all bats are mammals, and if all mammals have lungs, then all bats must have lungs. Similarly, if all trouts are birds, and if all birds have wings, then it would have to be true that all trout have wings. If all trouts are birds. Valid because in instance of this pattern, all P are Q, all Q are R, all P are R. So remember, we finally learned the concept of soundness in addition to validity. We said that an argument is sound if and only if we know that all the premises are in fact true and its form is valid. And how do we find out whether or not premises are true? Well, we have to go out and look or investigate. We have to go see through science or empirical method or just through our own eyeballs and hearing and sense experience, like you find out anything else is true, right? And that's not the concern of logic, but the validity part is. So all sound arguments are valid, but not all valid arguments are sound. So if you can show that an argument is invalid, you immediately know it's not sound, right? So remember, we'd learned early on to think about deductive arguments, where you attempt to cite, we attempt to cite evidence making the conclusion inescapable. And these can be invalid, where the conclusion is not inescapable given the premises. It could be false, as in the fallacy of affirming the consequent. Or valid, the conclusion is inescapable, in the sense that it's impossible for it to be false if all the premises are true, like, say, modus ponens or modus tollens. And then valid arguments could be sound, valid and in addition have no false premises, or they could be unsound. And if an argument is unsound, it's going to be either invalid or there is at least one false premise. So our first argument here about bats and lungs is valid and sound, but our second argument here about trouts and birds is valid but unsound. If all trouts are birds, then all trout would have wings, but that's a big if. So we learn that the only impossible combination of truth and falsity in a valid argument is to have all true premises and a false conclusion. So if an argument is valid with all true premises, its conclusion must be true. But if an argument is valid and its conclusion is false, at least one premise must be false. And here we do have a false premise, the premise that all trout are birds. So consider an argument with me. And not an argument, but in fact, consider an argument with me. And not an argument with giant G's and U's either. We'll get there. All right. So, consider an argument with me. Names do not name a lasting name if the world defies explanation. The Tao does not love to hide itself only if names do name a lasting name. If the world does not defy explanation, then the Tao does not love to hide itself. Therefore, the world defies explanation, just in case the Tao loves to hide itself. We make ourselves a dictionary. We're going to let W be the world defies explanation, N be names do name a lasting name, and L for Tao loves to hide itself. We then translate our argument. Right, and notice here I went in and I put the variables next to the constants so I could keep track of it when I put it into universal form. So the first premise is W, if W then not N, which is then P then not Q. The second premise is not L then N, which becomes not R then Q. The third premise is not W then not L, which becomes not P then not R. And the conclusion is W if and only if L, which becomes P if and only if R. So you can see how it can get confusing with the constants and variables, so you can check yourself by looking back at your little dictionary if you use this as a bookkeeping method. We then generate our truth table in the way we learned, right? Making sure to put a space so we get the not in a separate column. We number our premises, premise 1, premise 2, premise 3, and then the conclusion. We copy and assign all our truth values, and then we proceed to begin to calculate the truth value. But remember, we want to do the conclusion first. Why do we want to do the conclusion first? Because all we care about is whether or not we can find if we can have all true premises in a false conclusion. So obviously here, 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 and here, we cannot have all true premises in a false conclusion because the conclusions are true. So that leaves us, this is a possible instance, this one, and this one. So we only need to look at those 4 lines of the truth table. If you go through the truth table with me, we go to this line first. We've got true then false is false. So I don't have to do anything more here, because since I have a false premise, I can't have all true premises in a false conclusion. On this line too, true then false is false. So I can stop there. Again, I can't have all true premises in a false conclusion. But here, false then true is true, so I got to keep going. False then true is true, so I got to keep going. All right, but true then false is false, so I can stop. I can't have all true premises in a false conclusion. One more try. False then false is true. Got to keep going. False then false is true. Got to keep going. True then false is false. I can stop. Okay. A valid argument is an argument that's an instance of a valid argument form. An argument form is valid if and only if it's impossible to have all true premises in a false conclusion. When we analyze an argument with a truth table, there will not be any row or possible world where all the premises are true and the conclusion is false. So that's truth tables and validity. Another funny little thing to learn as we continue on our journey through logic. We have one more thing to learn about truth tables, and then we'll move on to something else. I want to thank you for your very kind attention.